Hi, my name is Sarah Heida, and I will be doing a hazard assessment on Volcán de Colima in Central America. Volcán de Colima is notorious for currently being one of the most active volcanoes in Central and North America. It can be found on the southwestern coast of Mexico and Jalisco, nestled between Guadalajara, Jalisco, and Mexico City. This area is well known for homing the Colima volcanic complex, a geologic formation that appears to have formed due to the subduction of the Rivera Plate and the Cocos Plate underneath the North American Plate. The resulting Colima rift formed the volcanic field in tandem with other rifts formed by the subduction zone within the Trans-Mexican Volcanic Belt. Volcán de Colima is on the southern end of the volcanic chain. Its larger brother, Nevado de Colima, is in the middle of the chain, just 5 kilometers north, and El Cantaro is the northernmost point, although this volcano is actually extinct. Volcán de Colima is an example of a very symmetrical, picturesque composite volcano or stratovolcano, and all three are considered to be mostly andesitic composite volcanoes with parasitic scoria or cinder cones. Upon closer inspection, while Volcán de Colima looks very symmetrical and appears to only have one vent, there are a number of parasitic venting cinder cones that have a large range throughout the volcanic complex. The volcano is predominantly andesitic, and therefore the magma is andesitic, making it usually viscous. The more viscous the magma, the more potentially explosive the volcano can become. This is because it has the potential for gas bubbles to form within the magma chamber, and if bubbles are present within a viscous liquid, they'll fight desperately to get out. Increased pressure exerted by the gas bubbles as they reach the surface can produce enough energy via pressure to trigger an eruption. It can also remain within the chamber, building pressure until the surface rock is either eroded away or damaged, thereby releasing the intense pressure that had been building within the volcano. Either way, when you have a more viscous magma, or lava, there is more potential for explosive eruptions, especially when it comes to composite volcanoes. Because it is one of the most active volcanoes in Central America, it poses a threat to humans that populate the area. According to a study in 2004, it has erupted in the past at least 40 times since 1576, with the largest eruption taking place in 1913 that we know of. There's evidence, however, of eruptions dating all the way back to at least 7690 BC, and it seems to follow a pattern of erupting violently approximately every 100 years, which is rather frequent in geologic terms. In the records collected from the 1913 eruption, there was a combination of ash flows with large blocks and pyroclastic surges. The whole eruption was caused by a magma mixing event, in which new volatile-rich magma is injected into the existing magma chamber, causing an increase in magmatic pressure. As mentioned before, the 1913 eruption resulted in block and ash flows and pyroclastic surges. A pyroclastic surge differs in a pyroclastic flow only in that the proportion of gas is higher in a surge and the proportion of rock and raw material is higher in a flow. This particular eruption left at least 3 layers or units of deposits. The first unit was comprised of a pale gray block and ash deposit, a beige pyroclastic surge deposit, 6 layers of gray block and ash deposits 7 meters thick, and a red block and ash deposit that had andesite fragments. The second unit held a layer of beige pyroclastic surge deposits with a cross-bedding, another 3 layers of gray block ash and flow deposit that was 12 meters thick. This block and ash flow also held pumice and scoria. There was also a layer of pumice lapilli to cap the second unit about 1 meter thick. Lastly, Unit 3 consists of the lapilli pumice, another pyroclastic surge, and 3 more layers of brown ash and pumice within a pyroclastic flow roughly 15 meters thick. While not all of Colima's eruptions have been catastrophic, many factors give it the probability of having calamitous episodes. Its proximity to two major cities, as well as many small towns, could spell disaster in the event of another pyroclastic flow. Larger debris is known to rain down from explosive volcanoes for miles around, and this is obviously hazardous to the surrounding populations. Composite volcanoes especially are known to be more explosive due to their viscous magma and narrow vents, and because of their steep slopes, they are susceptible to lahars. Even in the event that an eruption isn't immediately threatening human life, there's always the perspective that the resulting atmospheric disruption will affect agriculture, travel, tourism, and therefore the economy, and it could temporarily disrupt the weather in the area as well. These are all things to consider when beginning to compile a hazard assessment for an active volcano. The eruption of 1913 was certainly the largest eruption on behalf of Volcán de Colima, but some more recent activity took place over 5 years, from January 2013 to March 2017, with a resurgence of activity in April 2019. One thing to consider is the previous notion that Volcán de Colima experiences a Plinian eruption roughly every 100 years or so. The last one was in 1913, or exactly 100 years previous to the latest activity in 2013, and these latest eruptions resulted in ash plumes, lava flows, lahars, and pyroclastic flows. It doesn't appear that anyone died in these eruptions, but it was also reported that there were no evacuations despite the eruptions smothering towns in ash up to 25 kilometers away. As the eruptions continued over the next few years, the ash and smoke continued to fill the sky and fall, alongside the accompanying lahars and pyroclastic flows. This demonstrates that the volcano is still very active and still could have the potential to reveal a devastating blow to the surrounding communities should it explode in a violent manner as it has done in the past. Volcán de Colima is a dangerous volcano in a hazardous region and has the potential to be devastating to the surrounding environment in a multitude of approaches. There is the immediate danger to those who live in close proximity to the mountain, and according to a study in 2006, roughly 300,000 people live within 25 miles of the volcano. The risk of being caught in a pyroclastic flow or a lahar gets higher with the closer proximity you have to the mountain. There is also the risk of falling debris, which can range from ash size to house size depending on the explosion strength and geographic location. There's also the risk of economic loss due to evacuations and agricultural problems associated with ash columns and smoke. There was another large eruption that happened in 2005 where satellite monitoring indicated that an ash cloud had spread over an area extending roughly 200 kilometers. Pyroclastic flows and lava bombs were also found at a distance of several kilometers, and in this case the exclusion zone was set at 6.5 kilometers from the eruption site. Monitoring dome growth is pertinent to being able to predict when a Plinian eruption is imminent. Paroxysms or outliers in volcanic behavior need to be detected as well because although the majority of the volcano's history include fairly viscous lava, it was observed in 2018 that a very fluid lava was being exuded from the volcano, resulting in a fountaining column effect and pyroclastic flows. In my opinion, in the event of an emergency, I would say a 25-mile evacuation radius should be implemented or suggested at the very least, and a 10-mile exclusion zone should be required, implemented in the area to prevent any unnecessary loss of life. These types of volcanoes have extreme explosive potential and should never be underestimated.